These are the switch and mix nodes, for mixing and switching colours, shaders, scalars, materials, and so on. The regular Lightwave mixer node here is pretty straightforward. We get a foreground and a background colour, and an opacity of the foreground over the background. This opacity value can of course be driven by a scalar, such as a procedural. The foreground and background colours of course have inputs, so they can each be separate textures or coming from separate texture networks. We can use a gradient such as this to drive the opacity, of course, just using the alpha output, in this case on x coordinate, all pretty straightforward. We of course have blending modes here for how one colour is interpreted over the other. You'll notice of course that we do have a blending integer input here. Generally you won't use it much, nor have much call to, as it's simply a call for these, so normal is 1, additive 2, subtractive 3, or maybe it's 0, 1, 2, 3, I can't remember, check the manual. I rarely use it. Much more straightforward to just use the drop down. We then have DP's node, which appears identical for all intents and purposes so far as I can see. Color mixer, this is the true art version. Basically the exact same thing again, except with separate controls for the red, green and blue channels, which can be useful for achieving color shift effects. Note of course that since these guys are mixing colors, they can also be used to mix vectors in some creative ways. Mixing displacements, such as let's say MDDs. You can for instance input 2 of those, time offset one appropriately so as the beginning of it comes at the same point as the end of the other, and then animate the opacity value as appropriate. Give them a bit of time overlap and then blend them into one another if you desire. What they can't be dealing with, however, are material connections. That's incompatible. So when it comes to materials, we have our own nodes for them. First of all, the mixer, which is basically the same as the mixer that we've seen. I can take a pair of materials, again, an alpha value, and this gives me a way to blend and mix materials on a surface. Switch does something pretty much the same again, except that it uses an integer input. It's kind of like a stepped mixer. If the integer input is 0, you get the false material. If the integer input is 1, you get the true material. Why true, false? Sort of common and analogous to 0, 1, but weird naming to use on this node, I think. Anyway, if we for instance take our alpha from the gradient here, which is of course graduated, it won't matter if we plug it into switch, because it's an integer, and so it will round off and convert it as such. Therefore, because we're based on x coordinate here, then anything of 0 or below is getting the false material, and anything of 1 and above is getting the car paint material. As it happens, of course, don't forget that the range between 0 and 1 is also getting the conductor material here, because by wiring a scalar into an integer input, Lightwave has rounded down. If you give the integer 1.1, it becomes 1. If you give it 1.9, it becomes 1. If you give it 2.4, it becomes 2. And so on. So that's why we're getting the division at the 1 meter line. And there's the switch fella for us. Then we've got the really fun one, which is the multi-switch. If we open this node, we'll see that we can add additional inputs, and then of course select them and delete them if required. Let's say we give it 3 inputs here. Then what it will do is essentially the same as switch, except that each of these material inputs will correspond to a different number, namely 0, 1 and 2. Again, I'm going to use this x coordinate gradient here and map it to get scalar outputs of 0, 1 and 2 mapped across the x-axis here. So at -1 on the x-axis, we're going to have alpha 0, or material. At position 0, we're going to have alpha 100%, which is the scalar of 1, and at position 1 on x, we're going to have alpha of 200%, which is scalar 2. Take that, pump it into switch, material in, and there we go. However, unlike switch, which says that any value less than 1 is the false input and anything equal to 1 or greater is the true input, this will cycle. If I come into my gradient here, I'm going to put my end position at 3, just nip into modeler there quickly to stretch this guy out, give him a wider range of x coordinates. What we can see is if I add another key here at position 2, so 2 meters out on x, and set its alpha to 300%, so scalar 3, and I hook that up, see it cycles back to car paint again. If I add another key at 3, my goodness, do I actually have enough object for this? Will I have to scale him again? Nope, turns out I don't. But what we can see is with a key at 3 meters and an alpha of 400%, so 4, then we're back to the conductor again. So what multi-switch will also do is cycle through these materials. So you can input a set of integers here that goes up to any number you like, and it will count 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on, over and over and over. Now, when of course this becomes especially useful is when we're working with instances. So here we have an array of our guys, just a plain old rectangular array, as it will help us to understand what's going on here. What I'm going to grab is an instance info, which of course gives me an ID for each instance, plug that into switch, and there we can see we get a 1, 2, 3, 1, 2, 3, 1, 2, 3 of each material spread across the instances. What we can't do, of course, is start plugging materials into gradient color inputs to try and blend materials over space or some such. However, what we can do is this, is connect a couple of our materials up to a material mixer node, use the instance ID as the input to a gradient. Now I've got 5 by 5, so 25 instances here. So I can take that range of 0 through 25, although really it's 0 through 24, that's coming from the instance ID input. I can set the alpha value at this point to be 200%, obviously 0%, 100%, 200%, or 0, 1, 2 for the material count. Plug that into switch, and we can get a blend that runs this way. Here's the really cracking thing that I can do with the gradient set up like this though, is I can add a key in here somewhere which should ideally have an alpha of 100 to of course represent the 1 output. You see, I can drag it around and it gives me this ticking over of the different instances as I move the keys about, and so we can do things of that nature as well. Of course, because this is a scalar that we've taken here to plug into our switch, we can further manipulate this by multiplying it with textures or whatever else really. And of course, let's not forget the use of the material mixer used just by itself in this manner. With this same 0 through 24 gradient plugged into its alpha, then of course we can get a graduation between the two materials across the instances and play with those values in a similar sort of a manner. And of course, don't forget, you can always start taking the results of material mixers and plugging that into material switches, or vice versa, allowing you to get the graduated type behavior mixed in with the per instance behavior. Lastly, I do also want to give a quick mention to DB&W's material blender node, which is kind of like a material blender, splitter, combiner, all in one. Make material, split material, and material mixer. Background and foreground materials, or enter them as shaders, transparency and blending modes for each, and of course output in either material or shader component outputs. And there we have it. That's blending and switching. And there we have it. Those are the blend and switch nodes.